Hello everyone. So the genesis of this demo is a tweet from a pretty famous person, Jared Sumner. He's been the creator of Ben, and he has been in spotlight recently with the tools rapid adoption. I came across these recent tweets in which he states that he manually CodSigns every release. And after some research, I thought this would be a nice use case for Dagger. So because you can code the pipeline in any way. So basically I did a few research. I've been checking some projects that already exist. There is Gone, for example, that has been now deprecated and is supported on Mac. And there's been Relic. But the one I'm going to talk about today is Apple CodSign. So Apple CodSign is, let me jump right through it. Here it is. Okay, so Apple CodSign is a REST crate that has been designed that basically re-encodes the entire CodSign implementation in REST from Apple. So Apple has open sourced some of the CodSign code, and basically some of the community has been trying to port it to REST, which is really awesome. So let me show you. So the aim was to build an entire cargo, basically a module in Daggerverse about that. So as this is Rust, first we need to, so daggerverse.dev. I first had to build a cargo module to make this command line work. Okay, so basically, as you know in Dagger, you can build modules that will represent part of your pipeline. Here, what I want is to wrap cargo, the package manager of Rust, as an easy-to-use CLI command that runs inside containers, inside Dagger. As part of the pattern designs that I like, something I found really common across all the Dagger modules found online is, so basically you declare a type, here cargo, that represents a state in which you have a container here in the project, which will be a directory in which will be wants to run some of the cargo commands on it. So here I have the cargo build, I have the cargo format, cargo test, cargo clippy, which is really useful. And basically the one I needed here is the cargo install from Git. So the install from Git basically installs a CLI from cargo as a Git URL, and I'm just wrapping it. One thing I did add is I added a mounted cache. Why did I add a mounted cache? I added a mounted cache here because inside this Dagger cache volume, because as we are running in the context of a container, once this is built, what I want is to not reinstall it, re-download it, and then rebuild it, because this can be quite long as we're in Rust. Some other thing that I'm interested, so basically here, these are accessor functions to the project, to directly retrieve the project, here to retrieve the container with any installed package inside. What is interesting here, as I said, is that you have the type cargo. The container here represents a state. And what we can do, for example, is that with the install from Git, we now have set the state to a new container with the CLI installed. So here we now have access after running this command in Dagger. Sorry. After running this command in Dagger, we now have access to the container which has the installed CLI. So I think it's a really powerful pattern. One thing to consider though is that you need to have some check functions to make sure that any command that can be accessed from this state has everything required for it to be running properly. So here the prepare, for example, is being called in several places. Why? It's because I need to be sure to at least have a container inside to be running an exec. Here I need also to have a container and a state, maybe a directory to run anything. Yep. So basically that was the first part. So in order for me to run this CodSigner that is built in Rust, that is cross-platform, that would totally work inside containers and solve Jared's issue, I first needed to make a package, a module that enabled me to download that new CLI tool, basically. That was quite easy, as you can see, all in Go. Once the Rust SDK is ported, I can totally port it to Rust, no problem. So that was the first part. Okay, sorry. Then, let me show you maybe an example of that. So a nice example here is I prepared a small command. So let me go back here. I'm inside my Daggerverse. Usually we code Dagger modules inside a monorepo that I call Daggerverse. So here I have the cargo one, which I just show you on GitHub. Let me show you an example of that. So instead of using the same command, here I'm basically using the CLI. So Dagger call, I'm calling the install from Git function. Let me open it here, it's going to be easier. The install from Git function here. I specify a URL, which is here. This CLI is auto-generated. I put here the URL of the cargo binary that I want to download. On which branch, how do I want to call basically the CLI and basically rip, grep, and container. So here, I think what I can even do is a shell, like your shell. So nothing is cached at the moment. I can do RG, yep, and it works basically. So here I am inside a container. I just downloaded this from cargo and I'm running it inside. And basically, you can pipe this install from Git to have a container that has more and more tools. Okay. Now, let me go again on the presentation. So now let me introduce you the next part, which was the design of the code signature. So the code signature is a bit more easy because it's unfinished, it's a bit raw. So here first I had to create the CodSign, which is a wrapper about the CodSign Rust package that I showed you. I have a dependency here on the cargo module that I just showed you right before. And here is the implementation. The implementation is the same, basically. I still have a tab that represents a state. I have the source directory, which will be the directory on which I want to apply some of the CLI commands. And then I have the patterns, which I copied from basically Dagger's core std. The with source, the with PEM signature, the with P7, P12 signatures. So all these functions just add state to this CodSign structure, basically. And then I have the sign, which will basically do the actual CodSign. So here, what I do is I'm calling the cargo CLI subcommand, the cargo, sorry, here I'm calling the cargo module that I've been, on which I have a dependency. So what it does is that this module that I built, the other module has been installed and is now accessible inside my CLI. So if I do this cargo, I have it. So the install from Git installs basically the CodSign package here directly, and I'm returning the container from that. On that, I'm adding the source code, which is the directory containing the binary that I want to sign for. Then I'm adding the keys. So there are basically two ways to add the keys at the moment. I'm doing a perm key cert, and then I'm doing the P12 files. So for the demo I'm going to show you right after, I'm going to show you with these keys because it's easier for me to produce them and basically to show them. So here I'm just mounting this key and then basically calling the CodSign. And then I'm encoding the signature. And here I made another wrapper, the sign and export, that is basically calling this sign function locally here to sign the binary and then retrieve just the directory in which the binary has been signed. Why am I doing that? Is to rely on another Dagger command, which is Dagger output, and that takes the directory from the container and outputs it locally on my host. Okay, so demo time. So what I'm gonna do is I prepared here, let me show you, a small CLI tool. As you can see, it's very basic, but it's gonna serve the purpose. So I'm just building this app. Here it is. So as you can see, it's Mac binary, ARM64. What I'm gonna do is, sorry, CodSign. You can see that this has been signed, auto-signed locally. But what I can do, though, is I can remove this signature. So for that, I have the CodSign -- remove signature. And if I do it again, you can see that this code object is not signed at all. So this is the first part. The second part will be inside the CodSign. Is I'm going to, so here, sorry. Let me remove my previous example. Okay. So now what I'm going to do is I have here a demo, which is a PEM certificate cell sign, which contains the private key and the public key inside one file. So this has been generated just for the purpose of the example of the demo. So no worries, you can, I don't mind sharing it. Okay, so the first thing I'm going to do is I'm going to export this file here locally. So my bad. How do I close this? Oh, I can't. Okay. En pipe grep CRT. And yes, so we have it here basically. Then once this is done, what I want to do is I want to basically CodSign everything. So first I'm going to move the binary from, okay, tag, my go app test here. So now I have the test binary locally. And what I'm going to do is I'm going to call this command. So what is it? We have a Dagger download, sorry, which will download the directory that I showed you before in the .out local directory that is just basically removed. Here I'm just mounting the document mygo app. Also, I didn't have to copy the test with PEM signature, which is just the signature I just showed you locally, and then sign and export, which is a command. Let me show you again. Sign and export is this function basically, and basically the path will be test, which is the name of the binary mounted from this directory. So okay, let's run it. Yep, let's show. So I'm going to out, and now CodSign. You can see that this has been CodSign basically. So that shows the purpose, which is that you can indeed easily CodSign any Apple signature, any Apple binary, anything from Apple, use it inside containers, inside your pipeline. It can be portable. It's quite easy to use. As you can see, it was quite easy to develop to use in Dagger. The sign and export. There's a lot of tools and CLI things that you can do basically. So what's next? One of the biggest subjects of running code signature online in CIs is to be able to do remote signatures, as Dagger exposes the primitives to do container networking and things like that. I'm currently thinking about a remote signature process, a protocol that anyone can use to host basically their private keys in somewhere safe, be able to safely access them from the CI and to do remote signature. The other thing is the notarization. So here I have signed locally, but then once you have signed your app, you have to notarize Apple that you just did so that they double check that. So that's second part that can be added to this module.